Hi guys, welcome to your last section. Today we're going to be looking at solving trig equations. It's going to be pretty similar to what you saw in chapter 5 for some of the items, but we're going to go a little outside the box. Unfortunately, this isn't in your textbook, so you're going to be working off of a handout. I'm going to give you a few questions. Do your best. If you don't get the super tough ones, okay, work on them for next year. But it is kind of a really cool part of trigonometry that we can use. And it does go back. We do need to understand that trig functions will produce periodic functions in order to solve some of these. So when you are solving any equation, like a quadratic, for example, it means that you're looking for the x-intercepts. That is still true if we're looking at trigonometric functions. So there are multiple answers because our functions are periodic. So just keep that in mind as we go through. Now, solve each of the following for theta, where theta has to be between 0 and 360 degrees. So remember, we're just looking for one rotation of our circle. So this is something that you could have done very well on the first day that we had done it. If you take a look at cos x equals 0.6, x should equal the inverse cos of 0.6, and you should get, 0.6, and you should get around 53 degrees. Okay, now that's awesome. That's only one answer because we have our cast rule, right? C-A-S-T. This means that cos is positive in the fourth quadrant and in the first quadrant. So if 53 degrees is here, then we also have the angle down at the bottom. Now to get this one, I would have to go my 360 degrees minus the 53. So 360 minus 53, and that should give us 307. Okay, so this function or this equation has two answers. Theta could be 53 degrees, or theta can be 307. If you want to double check your work, take your calculators, plug in, cos 53, I get 0.6, and I'm also going to plug in cos of 307. I also get 0.6. So use your calculators to double check your work if you're unsure of your answers. Okay? It's kind of like having an answer key beside you if you've got your calculator. Okay, let's look at 1b. So this time sine of x is negative 0.75. Again, take the inverse sine. And when you plug that into your calculator, you probably get around negative 49. I know there's some decimals. If you follow proper rounding rules, you should end up at negative 49. Now, negative 49 degrees, if you think about your Cartesian plane, would be down here. That's an equivalent, right? Because we start at 360, but I'm going in a negative direction. So that's actually 311 degrees, okay? Because 360 minus the 49 puts me at 311. So sine of 311 degrees, right? Because 311 would have gone all the way around, should give you around negative 0.75. That's only one answer. Remember, trig functions are periodic, so there is another angle. Using our cast rule, C-A-S-T, because sine is negative, I've got to look in the quadrants that sine is negative. So they're all positive in the first quadrant. Sine is positive in the second quadrant, but sine is negative here and here. So I've got 311 degrees as one of my answers, and the other one would be in this quadrant. If this is 49 degrees, this should be the 49 degrees. So I'm going to take 180, because that would be kind of half of a circle, and I'm going to add my 49 degrees in this case to get my 229 degrees. Okay, so in this example, I've got 229 and 311 in order to make my statement true. Now, quick little side note, and this goes back to our graphing. For our sine, and again, I know that this doesn't look great, but if that's our sine curve, let's go tools again. If I want to know when sine is equal to negative 0.75, sine starts here. It has positive values, and then it crosses the x-axis and has a negative value here and here, right? I'm guessing there were, oh, sorry, I guess around negative 0.75. I guess they'd be lower. But there would be a negative 0.75 around here and a negative 0.75 around here. So it makes sense that we actually get two answers, okay? And then same thing with the cos idea, right? If you think about your grid and graphing it, it starts high, it goes low, it comes back up. We got an answer of 53 and 307. So if I'm looking at cos of 0.6, okay, well, or it goes up to 1, 0.6 would be around here. So there's probably the 53 degrees and the 307. Okay, so graphically, they make sense as to what's going on. All right, let's scroll down. You did see some examples with when we were in chapter 5 using your special triangles. So let's just slide these down a little bit. These are the answers, so you guys can double check your work as you go through them. I'm not going to do all of these. I'm just going to do 2. Actually, I'll probably do these 2. So let's solve. Again, we're solving for theta. Okay, I put x because the theta symbol sometimes gives me a hard time. So solve each of the following, where again, theta has to be between 0 and 360 degrees. It just means you're only going around your Cartesian plane once, okay? You're only staying your quadrants once, or you're looking at one cycle of your function. So again, if I'm looking for tan x equals 1 and I want to know what x is, take the inverse tan, but this one specifically says to use our special angles. So if I use my special angle and I isolate for x, I know that x is going to be the inverse tan of positive 1. Oops, let's put some brackets here. When you plug that in, yeah, you'll get a decimal, but you need to figure out, based on your special triangles, what angle will give you a ratio of 1. So there's no way I can use an opposite and an adjacent in this triangle. So I'm going to go to my special triangle with the 45 degrees. If I pick one of the 45-degree angles, opposite over adjacent, that's my tan ratio, would be 1/1, which would give me an answer of 1. So my angle happens to be 45 degrees. So x equals 45. Now, we have to again go between 0 and 36 degrees, 0 and 360. So they're all positive up here, only tan is positive down here. 45 degrees is in the middle. And then I would need to find the equivalent of 45 degrees down here. This is 180. 180 plus 45 is 225. So we are looking at a 45-degree angle and a 225-degree angle, okay? And we used our special triangles to get this one. Let's look at part B. Okay, you guys can do C on your own. So now I'm looking at sine of x equals 1/√2. The only triangle that has √2 is this one. So this is kind of nice also. Pick an angle. I am looking at opposite over hypotenuse. This angle of 45 does give me this ratio. So my x would also be 45. Again, look at your cast rule, right? C-A-S-T. Sine is positive, so I am looking in this quadrant and this quadrant. If this is 45, the reflection would be here at 45. So I'm looking at a 45-degree angle, and then 180 minus 45, okay, which would be 135, okay? So those would be your two values for x here, okay? And that's pretty much it for these guys. There is one more example hiding in the back that you guys can try on your own, and the answer is down at the bottom. Okay, so that's the basics. We're going to get into some fun ones. If you need a breather, pause the video, have a drink, okay, a glass of water or something, and then come back, because sometimes they can get a little funny looking. Let's do I'm not going to do A. Let's go straight to B. Okay. There we go. So I need to get x by itself. So I'm going to isolate for this term with the tan in it. Let's see, hold on a second. Oops, not all of it. I just want to copy this. There we go. Okay, let's get tan by itself. That means I'm going to take this 4 and I'm going to move it on to the left-hand side. Five minus 4 gives us 1. I need to bring the 3 onto the other side. It's being multiplied by tan. So when I bring it over, I am going to divide. Again, bear with the division symbol. There's no awesome special triangle. That would give me 1/3. So I'm going to use my calculator here. When you take the inverse tan of 1/3, you should get, I got 18. Okay, you should get 18. Now you've got to think about your cast rule. 18 would be up here, but tan is also positive in the 3rd quadrant. So that would be 18 degrees here, right? It's kind of like I'm rotating it every time. So if this is 18, this would be 180 plus 18, which would be 198, okay? So x is 18, or x equals 198, right? And basically what you're doing is you're solving these equations just like you would have with a quadratic function or any other function. We're just using trigonometry. Keep in mind, you're going to have more than one answer depending on what the value is. Okay, I do want to look at this one because you could have your inverse trig functions here. Okay, so let's look at this next one. I have 3 secant x plus 2 equals secant x minus 4. I'm going to take all of my values and bring them onto one side of the equation. So this would be secant x, when I bring it over, will be minus secant x. And then I would bring the -4 over to be plus 4. And on my right-hand side, we would be left with 0. Now, 3 secant x minus secant x, that leaves me with 2 secant x. Think of them like almost like variables, okay? And then plus 2 plus 4 would give me plus 6. And on the right-hand side, I have 0, okay? Now we're trying, actually, I guess I could have brought those over. Now we're trying to get the secant by itself. There we go. So I'm going to bring the plus 6 back onto the right-hand side. I did a little bit of a roundabout there. Sorry about that. So when this comes over, it becomes negative because we're subtracting it to bring it onto the other side. I also want to get rid of this 2. When I take the 2 and I bring it onto the right-hand side, it's going to be divided. I'm just going to save a step here. So when I divide both sides by 2, because at this point I assume you can rearrange equations, you should get -3 on the right-hand side because -6 divided by 2 is -3. So secant x is -3. We haven't dealt a whole lot with secant x. There's no secant x's on your calculator, but there is sine, cosine, tan. And secant is the inverse of cosine. So cosine of x equals -1 divided by 3 because they're reciprocal functions. Okay, so you can take the value and just take the reciprocal of it. So instead of secant, I have cosecant. Instead of secant, I have cosine, and instead of -3, it'll be the reciprocal -1/3. Okay, when you plug that into your calculator, you should get around 110 degrees. It's like 109.47, and if you round it, you get 109.5. And because 5 is even, the 9 would round up to 110. So you should get 110 degrees, okay? Listen, if you screw up your rounding rules, try not to do it, but I understand if that's the mistake that you're making, at least you understand the concept of trig. So one of my values is 110, awesome. Again, go back now to your cast rule. 110 degrees, so this is 90, 110 is up here. I need the other quadrant where it would be negative, so it would be kind of down here. So if this is 110, then to get this angle, I would have to take 360 minus 110, which is 250. So my x is 110, and x is also 250 degrees. Okay, and we have two answers. Okay, please pause your videos, take another drink of water, massage your head, put on your crash helmets. Okay, let's do 3 more examples. I hope you've got your crash helmets on. I know maybe these Looney Tunes cartoons, some of them didn't age well, but I gotta tell you, Wile E. Coyote is definitely one of my favorite characters. And this is very fitting for where we're about to go. If you feel like this, and you feel like Wile E. Coyote, stop the video, go for a nice relaxation, anything. Have some chocolate, do whatever you need. You might have some help moments. You might feel like an anvil is dropping on your head for a few moments. Don't worry, I promise you're gonna get through this with lots of practice. So we're gonna take all that solving that we did and we're gonna combine it with all of the fun algebra that we've done earlier in the year, like factoring and trig identities, and it's all gonna come together in one beautiful package. So let's get going. Let's take our 2 tickets and let's go to Crazy Town. All right, let's start with this one right here. We have an equation. It asks us to solve for theta, where theta is between 0 and 360 degrees. First step would be to factor. So actually, let's copy this out. There we go. So I need to get this tan onto the left-hand side. I'm going to subtract it from both sides, so I get 0 on the right-hand side. Now, you should notice that I have a tan theta in both terms. I'm going to factor out a tan theta from both terms. And when you factor the tan theta out, if I factor it out of this term, I would be left with cos squared theta. If I factor it out of this term, I would be left with 1. Now, tan theta times whatever this is gives us 0. If you go back to quadratics, this is your 0 product principle, where anything multiplied by 0 is 0. So in order to figure out what theta is, either tan of theta is 0 or cos squared minus 1 theta is 0. So let's look at each of these separately. So we're going to look at that one equaling 0. And then we're going to look at this equaling 0. Okay. Tan theta being 0 is actually not too bad. If you remember graphing your tan value or your tan functions, you end up with 0. You end up with theta equaling 0 at, or tan being 0 at 180 degrees and at 0 degrees. It's also, because tan is equal to sine over cos, tan is 0 when sine is 0. So in this case, by the way, you can use your calculator too. Theta will be 0. I'm just going to use x because of the theta symbol. Will be 0 at 0 degrees or 180. Okay. And again, if you think about your cast rule and you plug the inverse tan of theta into your calculator, so inverse tan is 0, you will get 0. And if you rotate it, it would be over here at 180 also. So those would be the 2 times. Just for those ones that end up on the axes, just double check with your calculator. Okay, this one's a little bit more fun. Cos squared theta minus 1 equals 0. You could actually use a trig identity right here, but we can do it straight from what we've got. So cos squared theta minus 1 is 0. I have to figure out, I have to get the theta by itself. So cos squared theta equals positive 1 because I've taken the 1 and brought it onto the right-hand side. Now I need to figure out when cos squared theta equals 1. So I can take the square root of 1. And you should get plus or minus, oops, sorry. You should get plus or minus 1. So cos squared theta equals 1. When I take the square root of both sides, the right-hand side is plus or minus 1 because 1 times 1 is positive 1, but also negative 1 times negative 1 is positive 1. So we have to find the values for theta when cos is 1 or cos is negative 1. You may use your calculator. You can also think about the CAS rule. It happens at 0 degrees also. And it also happens at 180 degrees also. So in both scenarios, our X values are the same, okay? They won't always be. This just means we only have 2 answers for this scenario. So theta for this function, this statement is true when theta equals 0 or theta equals 180, okay? So long story short is you can factor them, okay? All right, Crazy Town, let's just move you out of the way. Okay, let's look at a different example here. This one is kind of cool because we're going to have to replace and do some serious factoring. Now, I'm going to take this. When I answer these, I actually keep my sign values, but I want to show you something. I've got 3 sine squared theta minus sine theta minus 2 equals 0. If these were not sine, let's just say s. Let's pretend it was a variable. 3s squared minus s minus 2 equals 0. That's a quadratic. You should be able to solve it. Forget s. Let's use a letter that you're used to seeing. 3x squared minus x minus 2 equals 0. You can absolutely factor that. That's going to be 3x. Let's go 3x and x, and then one of them would have a 2 and one of them would have a 1. Now, let's see. Now, remember, there are methods like decomposition for these ones here when there's an a value, any kind of complex trinomial we guessed and tested. You could use your quadratic formula, but that would take too long here. So now we just play around with your positive and negative signs until you get the right signs. This should work. 3x times x is x squared. Positive 2 times negative 1 is negative 2. This 3x times negative 1 is negative 3 plus 2x. Yep, I get negative x. Okay, so I factored properly. But instead of x, I had sine. So let's just replace this with sine theta. Oops. So now I've got this times this equals 0. You've got to figure out when this is equal to 0 and this is equal to 0. So let's look at each one of them. Okay, so I've got to find out what values of theta will put this bracket equal to 0, and I have to find out what values of theta will put this bracket equal to 0. This one is easier, so let's do this one first. I have to get sine theta by itself, so bring the 1 onto the other side. You should be left with sine theta equals positive 1. When you plug that into your calculator or you think about your graph, sine theta is equal to 1 at 90 degrees and only 90 degrees. So this angle here, theta equals 90 degrees. And if you don't have those values memorized, plug the inverse sine of 1 into your calculator. You'll get 90, and then just go back to your cast rule. Okay, so there's one answer. Now let's come over to this one. Sine theta plus 2 equals 0. I'm going to bring the 2 onto the other side. It'll become negative, and then I need to divide both sides by 3. I'm just going to do this kind of in one line. You can take the inverse sine of negative 2 over 3, plug it into your calculator. You should get theta equals around negative 42 degrees. Okay, these negative ones are a little bit funny, right? You've seen those before. So negative 42, if this is at 0 degrees, negative would go in this direction at 42. So I know it's 0 degrees, but it's also 360. So 360 minus 42, you should get 318 degrees. I'm looking for anywhere that sine would be negative. So C-A-S-T. Sine is negative down here, and sine is negative down here. So I would also have the 42 degrees here, which would be 180 plus the 42, which is 222 degrees. Okay, so for this guy, let's just do this. I'm running out of room. Uh-oh, there we go. So theta would then be, we had 222 and 318. Okay, so as your final answer, theta is 222, 318, or 90, because we have 90 from this side as well. So these are your 3 possible answers for this question. Okay, so this is really all that you're doing. Is you can factor, you can solve for theta. Okay, there is one more I want to do with you, because you do have to use your trig identity here. And there is factoring. So this is a super nice question from my point of view. You might be ready to cry. Grab some tissues. It's okay. You'll be fine. Just imagine I'm patting you on the back. You're going to be okay. All right, last one. So here we have cos squared theta minus sine squared theta plus sine theta equals 0. This has a whole bunch of crazy things going on. What you should first realize is that this is sine squared and this is sine squared. If they were all the same trig function, you might be able to do something with factoring. So I'm going to take cos squared theta and I'm going to use my trig identities. I'm going to use the trig identities to make that look a little better. So cos squared theta, let me put this in brackets just to make this clear. We had a trig identity that said that cos squared x, I'm just going to say 2x, I know that's not right, plus sine squared x equals 1. Okay, this was one of your trig identities. Okay, they're squares, not twos. So if I needed to get this guy, bring the sine squared theta or sine squared x onto the other side. And you should get cos squared x by itself. So I'm going to replace cos squared theta with 1 minus sine squared theta. Okay, so all I've done is I've replaced this with 1 minus sine squared theta, which was your trig identity. Okay, all right, now I can remove the brackets and I can collect my like terms. And I'm going to do this in one step because you guys, I'm sure, are seeing this is going to take a while. So 1 minus sine squared theta, there we go. I'm going to collect my like terms, these two right here. Negative sine squared minus sine squared is negative 2 sine squared. And I can eliminate this now. Okay. Now, taking a look at this, I notice that I've got something squared plus something and another constant. I'm going to reorder them so the squares are written first. And what I'm actually going to do is move them onto the right-hand side so I can just eliminate the negative sign. So just bear with me in the next line as I make things look a little bit prettier. So we should end up with a positive 2 sine squared theta minus sine theta, and then minus 1, right? Because I've taken this, brought it onto the right-hand side to make it positive. Right, so I've taken this, brought it onto the right-hand side to make it positive. I've taken this, brought it onto the right-hand side to make it negative, and this onto the right-hand side to make it negative. This should look like something that you can factor, which is what we are going to do now. If you do not like factoring with signs, just keep an S. Please imagine the theta is still there. I'm just eliminating it for now so you can see what's going on with our factoring. Okay, so let's factor. We should get 2 brackets. It is a complex trinomial, which means there is going to be a 2 or a number in front of one of the values, and they're probably going to be a -1 and a +1. You just have to figure out where they go. This one here, you can guess and test until you get it, but the positive sign goes with the bracket that has the 2. All right, now remember this S represents sine theta, so let's just rewrite this now. Actually, let's do this. I'm going to replace all of my S's with sine theta because that's really what was supposed to be there. And now your job is to figure out when each of these brackets would be equal to 0. So when this is equal to 0 and when this is equal to 0. All right, let's do, it really doesn't matter. Let's do this one first. And then we're going to do this one second. Okay, so this one here, they both have to equal 0. I have to get theta by itself. I'm going to bring the 1 onto the other side. The 1 would become positive. Take the inverse sine of 1. And you should get an answer of 90 degrees. Because there is only one value on your graph where theta, there's only one theta value on your graph where sine would give you a +1. It only happens one time. And there it is, it's at 90. So there's only one answer for this side. Now let's look for this side over here. Again, I have to get theta by itself. I'm going to bring the 1 onto the other side. It would become negative. Now I need to divide both sides by 2. This would be -1 divided by 2, which is -0.5. Take the inverse sine of -1/2, and you should get, hold on, not 330, just 30. Okay. Oh, sorry, -30. Now, our stipulation says we cannot have a negative angle because they specifically asked for degrees between 0 and 360. So take this -30, go back to your Cartesian plane. -30, right, would be in a negative direction. So that means that if this is 360 minus 30, this would be 330 degrees. Again, think about cast rule. If it's 30 degrees here, it should be about 30 degrees here. In order to get the full angle, I would have to go 180 plus 30. 180 plus 30, is 210 degrees. Okay, so we are looking at 330 and 210. So theta, to put it into our restrictions, or to match the restrictions that they gave us, theta equals 210 or 330. And then to finally answer your question, or to answer the question completely, theta had 3 possible values that we could pick from. So theta equals 90 degrees, 210, or 330. So there are 3 possible times, 3 possible angles that would make this statement up here true. Okay, so I know that was a lot. I know this is a long video. I apologize, but you can solve trig identity. You can solve trig functions using trig identities, factoring, any other technique that we have used throughout the year. Some of them are really pretty from my point of view. Some of them are really ugly, but either way, don't worry, you guys got this. So do your best. You might feel like this right now. You're definitely going to feel like the Roadrunner instead of Wile E. Coyote after you've practiced a few. I have a handout with a bunch of questions for you to try with answers. Okay, guys, have a great one. You finished trigonometry. Give yourselves a pat on the back. Take care. We'll see you in the next unit.